Hello, this is Mr. Stansberry. I'm going to take you through the 6K index laws notes. At the end of this, you should be able to apply all the index or the power laws with both constants and variables. And there's a lot of index and power laws. So it'll take us a little while, but we'll get through it, and they should make good sense. So let's take a look at what all the laws are. Okay, so I'm going to show you not just what the power laws are, but how they work. So then when we get to trying a bunch of examples, then we'll be good to go. All right? So first thing, if you have x to the fourth times x to the third, that's really the same thing as 1, 2, 3, 4. There's my x to the fourth. And then 1, 2, 3, x to the thirds. So that's really x to the 1, 2, 3, 4, 5, 6, 7. So what we're really doing is taking x to the seventh is our answer. So really the easy way, hopefully, that you can figure out that is to just add the exponent. So that's x to the 4 plus 3, which is x to the seventh. Okay? So the general way to write that is, and this is how all of these are on page 192 from your book. So the nice way to write that is, they've got it as a to the m times a to the n equals a to the m plus n. Okay, and those again are not nines, those are a's. Alright, so that's the first one. Second one, x to the fifth divided by x to the third. So again, another way to write that is 1, 2, 3, 4, 5. There's my x to the fifth. There's my x to the third. And those will cancel, and these will cancel. And you're just left with those when we're done. So we get equals x squared, right? So the easier way to write that, or the easier way to calculate this, hopefully, you would figure out, you would go x to the fifth, and you're going to subtract instead of add the exponents. You're going to subtract them if they're over the top of each other. 5 minus 3, which is x squared, right? So the general form way to write that is a to the m over a to the n equals a to the m minus n. Okay? So these formulas here, you may get worried, just like, oh my gosh, we've got 1, 2, 3, 4, 5, 6, 7 of those. Yes, but once you use these a couple of times, you won't even have to worry about these formulas here. You'll just start remembering how to do all these, and so you don't need to get stressed out about having 7 different formulas all figured out, okay? Because should just start coming naturally as we go. Okay, so x squared to the third power. A way that we can rewrite that is what we truly have here is x squared 3 times, right? So it's x squared times x squared times x squared. Okay. From back up here, when we have a power with the same bases and we have the exponents up here, we're going to add those exponents. So that's really x to the 2 plus 2 plus 2 is x to the sixth, right? Okay. Now hopefully the easier way to do that is just say, oh wait, I've got 3 sets of 2. So to do that quickly, it's going to be x to the 2 times 3. So we just multiply those exponents, which is x to the sixth. Okay? And the way we write that is a to the m power raised to the n power is a to the m times n. Okay? Let's take a look at the next one. xy to the third. Again, you can write as xy times xy times xy. And if there's no number, no power written out there, it is assumed, and it's always correct, it's always 1. So really that's x to the first, y to the first, x to the first, y to the first, x to the first, y to the first. So really we have x to the 1, 2, 3, add those all up, x cubed and y cubed, right? So really all you're doing is taking, x to the third, all you're doing is basically just multiplying these exponents together just like what we did here, but you just have 2 of them now. Okay? So the way we would write that is excuse me, ab to the n equals a to the n times b to the n. Right? You just distribute that power through to both of those. Alright, let's take a look at this one here. X to the fourth, xy all to the fourth. X over y 4 times. X over y, x over y, and x over y. So again, if you think about that, it's just 1, 2, 3, 4 x's on the top, x to the fourth over y to the fourth, right? So again, you just take this 4 and distribute it to both the top and the bottom. Okay? So we would write that as, if we had a over b all to the nth power, it's the same thing as a to the nth over b to the nth power. Okay. 3 to the negative second. This is one that we hit right at the end of the last set of notes. And what you want to do with this here, 3 to the negative second, is the same thing as you want to just take this negative exponent and move it to the bottom. So it's 1 over 3 squared. Okay? And that's really all you need to do with that. You could write it as 1 over 9 if you really wanted to, but either way is fine. So that power law is written like this. We have a to the negative n equals 1 over a to the n. Okay? And then last one here, we have 7 to the 0. And pretty much anything to the 0 power just equals 1. Okay? So that's the nice part here. As long as this base doesn't equal 0, then it's going to equal 1. Okay? So we would write that as a to the 0 equals 1. And again, they did put a little stipulation. A cannot equal 0. Okay, so these are all the power laws, and here's how they all work. Okay, let's take a look at some examples, and we've got just to be completely fair with you, we've got a fair amount of examples through here, and I elected to go through every set of examples just to make sure that you've got this all down. So again, feel free to write down the ones that you feel like you're gonna need to have all written down. Alright, so we're going to move fairly quickly through this, otherwise it's really going to drag on. So this is our first power law that we did. So using this power law, a to the m times a to the n equals a to the m plus n. Feel free on all of these, once you see these, say, hey, wait, I can do that. Do it on your own first, and then push pause, do it on your own, and then play the video back and make sure that you got the same answers that we did. And if you didn't, then obviously just check and see what what went wrong, and then adjust on that. So this really is saying 11 to the 5 plus 3, which gives us 11 to the 8th. Alright? Add the exponents here. A to the 4 plus 5 gives us a to the 9th. Excuse me. And then x to the 4 plus a, that's not a 9, that's an a. And you can't simplify that at all, so you just leave it like that. Okay? So that's our first set of examples.